B-31, Convair's first tactical B-58. This hustler represents more than 3 years' effort in the manufacturing, testing, and development of a supersonic intercontinental bomber for the Strategic Air Command. A notable airplane, a notable number. To understand better what makes a tactical B-58 tactical, let's take a preliminary ground tour. First, notice that airplane 31 presents the same external features as earlier B-58s. Prominent among these is the delta wing, designed for greater stability throughout all speed ranges. Notice also the slender fuselage with its slight Coke bottle shape, an important factor in reducing drag. The ailerons and elevators of conventional aircraft are combined on this wing to form elevons that give the B-58 exceptional maneuverability. Next, we'll take a short step to the main landing gear. This consists of 2 struts, each carrying 4 double-tired wheels. These improved tires have fabric-reinforced thick treads, which show high resistance to cuts. The small size and light weight of the 2-tire assembly allow a much simplified operation of changing. One man can do it. The average time for this operation is approximately 15 minutes. Next, we have the J79-5A jet engines suspended beneath the delta wing. These reliable engines can push the Hustler to over twice the speed of sound. The variable position inlet spike, one of many B-58 firsts, is indispensable for supersonic flight. When in the extended position, the spike pushes back the strangling effect of shock waves built up at the engine inlets at Mach 1.3 and above. The power for all B-58 systems is also delivered by the J79s. As we transfer our scene briefly to inside the factory, notice that the engine nacelles are made up of panels giving complete and easy accessibility to internal working parts. This is made possible chiefly because of the use of Milson fasteners. Combining ingenuity and simplicity, this small item, in fact, contributes importantly to B-58 structural integrity. The nacelle panel, like most of the B-58 surface skin, departs from conventional airframe structures by using layers of materials bonded under pressure into a sandwich. The inner layer, or core of the sandwich, is honeycomb. 3 types of honeycomb have been developed, each suited to a specific application. Fiberglass, used as the skin of inner fuel tanks, aluminum, found in the wing and fuselage, and stainless steel, used in the engine nacelles and other areas where resistance to high temperature is necessary. Let's now turn our attention to the pod. At this point, some background information may be in order. Without probing too deeply into design concepts, it's well to keep in mind that the B-58 is thought of as a 2-part weapon system. The return component, which is the airplane itself, and the disposable element, which is the bomb pod containing the payload. There are several types of pod. The first is the MB pod, which is comprised of 3 main parts: 2 fuel tanks in the tip and tail sections, and the center-located payload. The fuel in these pod tanks is used on the outbound leg of the flight. Let's now turn to the 2-component pod. As its name implies, the TCP, now being developed to increase the versatility of B-58 performance, is 2 pods in 1. The upper component contains the payload, while the lower component is a disposable fuel tank jettisoned after its fuel has been expended. Early disposal of the pod reduces drag on the outbound leg of a mission, thus substantially extending the Hustler's range. Perhaps the most significant advantage of the externally carried pod is the elimination of bomb bays and the larger fuselage necessary to envelop them, which contributes vitally to the small size and high speed of the B-58. These factors mean, in turn, the concrete, realizable strategic assets of quick reaction operations and dispersed basing. using approximately 300 airfields, both military and civilian, in the United States, as well as many overseas. As we come back to airplane number 31, note the tandem arrangement of crew compartments, distinctively B-58 in design. The first station, or pilot's cockpit, the second, or bombardier navigator station, and the third station, occupied by the defense systems operator. For convenience of demonstration, let's first review current arrangements in the B-58 for escape, as represented by the improved sack seat. This has better extremity restraints to prevent flailing of arms and legs caused by impact with high-velocity slipstream after ejection. Before takeoff, let's continue our demonstration with some examples of how human engineering has fitted the cockpit to its occupant. Communications and flight controls, including autopilot, are grouped within easy reach on the left side of the cockpit in the same general area as the throttles and other engine controls. This allows the pilot to change autopilot modes without removing his hand from the control stick. The emergency brake and landing gear handle and the emergency elevator ratio handle are positioned for a convenient pull angle. Near landing gear controls is the drag chute handle, while on the other side, switches for cockpit lighting are close to the pilot's right hand. Caution and warning lights are consolidated on these special panels, and a master caution and warning light is located on the pilot's instrument panel. All right, with so much under our belts about number 31, let's get ready to go. Now, let's go. Designed primarily as a high-altitude intruder, this airplane has now added a proven low-level capability. And how? Here we go skimming cross-country at nearly supersonic speed. The sturdy delta wing, meanwhile, affording a crew comfort never before experienced in a bomber at this just above the ground level. Now let's go to the second station, where the crewman's prime concern is the bombing navigation system. The bomb nav system, continuously comparing information from its various primary sources, automatically arrives at the data necessary for position fixing and weapon delivery. This information is also fed into the autopilot when this mode is selected for guidance of the aircraft. Our next stop is the third crew station, Control Center for the Active and Passive Defense Systems. The active defense system consists of a radar-controlled, rapid-fire 20mm gun mounted in the tail. The passive defense system is made up of radar warning devices which alert the operator as to the presence of enemy radar, track breakers which protect against guided missiles, and confusion devices defending against enemy ground stations. The air conditioning system has the dual job of cooling these electronic packages and making the crew compartments habitable. Normally, cooling air flows first into the cabin, then into compartments housing delicate electronic instrumentation. Should the equipment require emergency cooling, the flow can be reversed so that the cold air flows over the electronic packages first.
Spotted our tanker on the right. She's right on schedule.
Yes, Airplane 31 has a complete and efficient in-flight refueling capability from tanker aircraft currently in use with other intercontinental bombers. The receptacle for in-flight refueling is the most compact available today. The door of this receptacle is unusual in that it retracts into the airplane, eliminating the possibility of damage. During refueling, a process which in actual operations requires some 15 minutes, the pilot has an unobstructed view of tanker and probe. After disconnect, the B-58 drops away from the tanker, and the pilot can now trim out his ship by fuel transfer if needed. In addition to its prime function of feeding the engines, the fuel system may be used to shift the airplane's center of gravity either automatically or manually. This is accomplished by transfer between the system's 5 tanks: the forward tank, reservoir tank, aft tank, balance tank, and pod tanks. The reservoir tank is always kept full to be used last. A special duty reserved for this tank is supplying fuel to the engines during periods of rapid deceleration or negative G conditions. So much then for the fuel system. Enlarging on our earlier coverage of the improved sack seat, let's next have a look at its eventual successor, the escape capsule. There are 2 capsule configurations, one for the pilot station and the other for the second and third stations. With their operating principles essentially similar, let's select the pilot station for demonstration. Shirt sleeve flying is possible because the capsule eliminates the need for pressure suits, bailout bottles, and parachutes. In short, the capsule is complete unto itself, containing as it does its own pressure, oxygen, and recovery systems. It's the best answer to ejecting at high speeds and altitudes into sudden wind blasts and the numbing cold of rarefied upper air. It will also serve as shelter for a crewman, either on land or water. As the Hustler prepares to touch down, let's note a few more distinguishing facts about its landing gear. The spidery length of strut gives the pod ample clearance on landing or takeoff. Notice again those wheels, whose diminutive size allows a neat tucking away within a minimum space under the wing. Our flight completed, let's follow Airplane 31 down to the deck. Besides the previously mentioned broadening of B-58 mission capability, the low-level steadiness imparted by the delta wing favors the pilot greatly on takeoffs and landings. This built-in stability helps materially to compensate for sudden wind gusts and downdrafts, as well as deviations from optimum speed and rate of descent. So this is B-58 number 31. A powerful airplane, a steady airplane, a versatile airplane, a swift airplane. By embodying all these qualities in full measure, Airplane 31 has also become a first airplane, the first tactical B-58.